So I said for two vectors which are at vectors P and Q, which are at angle theta to each other. I said the resultant is drawn from the point of intersection of the line of action of the two vectors. This is the point of intersection of the line of action, and this is the resultant. And that resultant is R. And I showed there was your R squared is vector P squared plus Q squared plus 2PQ, then cos theta, where theta is the angle between the two vectors. Okay? When is your R maximum? This was the question I asked you in the last class. When is the resultant maximum? Resultant is maximum if theta is 0. Resultant is maximum if theta is what? 0. That is P and Q. Watch that. P and Q are parallel. When P and Q are parallel and in the same direction and act in the same direction, in the same. When P and Q are parallel and act in the same direction, and act in the same direction, that's when we have our resultant maximum. Meaning P act like this, Q act like this. Okay, your resultant is simply P plus Q. If you put theta as 0, put theta as what? 0 in this place. Put theta as 0 in this place. You have P squared plus Q squared plus 2PQ cos 0. And cos 0 is 1. Cos 0 is 1. So now what? You need to have R squared. You need to have R squared equals, sorry? You need to have R squared equals P squared plus Q squared plus 2PQ cos 0. Cos 0. Now, your cos 0 is 1. Your cos 0 is 1. Cos 0 is 1. So you have R squared equals P squared plus Q squared plus 2PQ. This is what you have because cos 0 is 1. And you have the what? R squared equals P plus Q all squared. Take note of that. Because P squared plus Q squared plus 2PQ is P plus Q all squared. Is P plus Q all squared. And what happened? 2 cancel 2. Your resultant is P plus Q. So the highest resultant, the greatest value you will get when you combine P and Q together, the greatest single force you will get is P plus Q. So we say the resultant is the maximum when theta is 0. And for the engineering student, you can do your calculus. You can do the R d theta. You can differentiate R with respect to theta, and you get theta as 0. You equate this to 0 and find the value of theta. But that's not this engineering class. This is science class. So let's go on. So that's this one. That's 1. Then 2. 2 is when is your resultant minimum? When is resultant minimum? When is resultant minimum? Which means when we have the least value of resultant. When we have the least value of resultant. Resultant is minimum when theta is 180 degrees. When theta is 180 degrees. Let me show you again. We are done for this. Let me show you again. Look at it. This is vector P. This is vector Q. Or PQ or QP. Anyhow. This theta. So very good. If you close this angle, if you close it, what happened? Theta reduces. If you bring this line down, theta reduce. Bring it further down, theta reduce more. Bring it further down, theta reduce more. Until it lies here. That means P and Q lie on each other. This is when theta is 0. But if you do the other way around, this is the angle between P and Q. If you open here up, theta increase. If you open it more, theta increase. You open it more, theta increase until you get here. That Q will be acting like this, P will be acting like this. What is that the angle between P and Q in this case? Anybody? Sorry? I can't hear you. Okay, 180 degrees. So just take note that your resultant, you can't see the board. Can somebody see the board? One person. Yeah, you have to check him. You have to check the network. Thank you. Thank you. So when is your arm, that guy should check his network. When is your arm minimum? When is arm minimum? R is minimum when theta is 180 degrees. This is when R is minimum. So put theta as 180 in our formula. You have R squared equals P squared plus Q squared plus 2PQ cos 180. That's R squared equals P squared plus Q squared minus 2PQ. Why? Because cos 180 is minus 1. Is minus 1. Cos 180 is minus 1. Cos 180 is minus 1. So what do you have here? Your R squared is now P minus Q all squared. Is P minus Q all squared. How do you get that? P squared plus Q squared minus 2PQ is simply P minus Q. So R is now P minus Q. This is resultant. This is the minimum resultant you can get. This is the maximum resultant you can get. And this can be P minus Q. You will say in direction of P. It can be also Q minus P, but in direction of Q. If P is greater, just imagine a 10 Newton force pulling a body like this, and a 7 Newton force pull the same body like this. What direction will the body go? 10 Newton. God bless you. God bless you. So what is the resultant of these two forces now? What is the resultant of these two forces? That will be 10 minus 7. Yes, it's 7. Yes, thank you. 10 minus 7, that's for 3. Good. Is it to the east, or to the west? To the east. To the east. Which means direction is very what? Important. Direction is very important. If I have said 7 minus 10, what would I have gotten? If I say 7 minus, I would have gotten minus 3 Newtons. But in what direction will this one be? In what direction will it be? To the west. It's to the west. To the west. Okay? That's the direction. It's to the west. Okay? So if you do 10 minus 7, then we are saying in direction of what? 10. If you say 7 minus 10, that means in direction of 7. If I say P minus Q, it means in direction of P. If I say Q minus P, it means in direction of what? Of Q. So you must take note of that. That's the second point. When is your R maximum? You have gotten that. When is your R minimum? You have gotten that. The last one is, when is your resultant 0? When is your resultant 0? Number 3. When is R equals 0? Now watch. R is 0 when P and Q have the same magnitude. That's 1. The value of P and the value of Q are the same. and the angle between them is 180 degrees. When the value of P and Q, the magnitude of P and Q are equal, and it's also angle 180 degrees. So watch, we have said when the angle is 180, resultant is either P minus Q or Q minus P. These have been established. When the angle is 180 degrees, either P minus Q or Q minus P. That has been established. Okay? Now, but if magnitude of P and Q are now the same, values of P and Q are now what? The same. Then that means P minus Q is 0, Q minus P is also 0. That's where the resultant is 0. Number 4 is when theta is 90 degrees, what is your resultant? Your resultant becomes R squared, P squared plus Q squared. God bless you. Because if you press cos 90 here, cos 90 in the equation, this cos theta. But now, theta is what? 90. If you press cos 90, you get 0. 2pq times 0 is what class? 0. So that left to what? R squared, P squared, and what? Q squared. Good. In that case, we say P and Q are perpendicular to each other. Am I correct? Yes, sir. Okay. So, and the resultant is obtained using what? Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. That's the resultant. This is P. This is P. This and theta. The resultant R squared is P squared plus Q squared. Pythagoras theorem. Okay? So let's see an example sharply. Let's see an example very fast. Right, please. Example. Right, please. 2 forces theoretically. 2 forces, 6 newtons and 8 newtons act on a body. Please mute yourself, that guy. Mute yourself. Mute yourself. 2 forces, 6 newtons and 8 newtons act on a body at rest. Act on a body at rest. Determine the resultant force for the following, for each of the following cases. For each of the following cases. 1. When resultant is minimum. 2. When resultant is maximum. 3. When the forces act at an angle 60 degrees to each other. 4. When the forces act perpendicularly to each other. 5. When they act at 120 degrees to each other. Okay, so now I've captured all the possible questions I can set in your exam for you. on this topic, on this area, there is no question I'm not asked on this area of your exam. There is no question I'm not asked. If they don't ask you for minimum, they will ask for maximum. Or they will say when they are at angle B, or they will say when they are perpendicular, or they will give you a larger angle. This is all you can ask on this topic, okay, on this aspect. So let's quickly solve them. Let's quickly solve them. So the forces are what? I will call them P is 6 newtons, Q is 8 newtons. I'm free to use any symbol I like. Just like you are also free to use P or Q as you like. F, S and Y is your choice. So question 1 says I should find resultant when the resultant is minimum. I should find the resultant when the resultant is minimum. Now, watch please. Another way of saying this is, instead of saying when R is minimum, another way of saying it is that when, they will say when both forces act on a straight line in opposite direction. This is how we ask it. But I will say when the forces are at angle 180 degrees to each other, I want to note all the possible things you can say, which means the same thing. When the forces are on a straight line and opposite each other, 6 newtons is here, 8 newtons is here. You see the same as saying when R is minimum. So in summary, answer is 8 minus 6. That's 2 newtons. In direction of who? In direction of which one? Like in the direction of 8 newtons. Don't say east or west, because diagram was not drawn. We didn't see any diagram. Just say in the direction of the force you pick first. You pick 8 before 6. So 8 minus 6 is 2. In the direction, that 2, force is a vector. You must have magnitude and direction. You can't give me 2 newtons without giving me direction. So 2 in the direction of what? 8 newtons. If you say 6, watch. If you say 6 minus 8, you will get minus 2 newtons. You will say in the direction of 6 newtons. You must watch it. It's your choice. Number 2, say when R is maximum. R is maximum. Maximum R is P plus Q. Your maximum resultant is P plus Q. Now, watch. Please mute yourself. R is maximum. Maximum value of R. This is the minimum value of R. This is maximum value of R. Now, when you are finding maximum value of R, another way of asking the same question is when they are in the same direction. When the two forces act in the same direction, they both act east, they both act west, they both act north, they both act south. The forces are in the same direction. That's when R is maximum. Or they will say when the angle between the forces is 0, it's 0. So answer P is 8 or whatever, 6. That's 14 newtons. Please, who can tell me in what direction will these 14 newtons be? Both the physical people, you can tell me the answer. You know the answer. Yes, that's correct. That's physical student. In what direction will it be? No, there's no east or west in the question. You don't have east. Yes, you say into. God bless you. in direction of both 8 and 6. If two forces act like this, in what direction should their total act? If two forces, God bless you. So you say what? In direction of any of them, of any of the forces, of both of the forces, any means of both also. That's number 2. Done. Number 3 says, when the forces are at what? They are at angle 60 degrees to each other. When the forces are at angle 60 degrees, to each other. What does that mean? One is like this. Let's call here 6, it's my choice. Let's call here 8, it's my choice. Okay? They're not at angle what? 60 degrees to each other. I need your attention. Okay? So, this will be done by using parallelogram law of vector addition. Though all these have been done by the same method anyway. The resultant is drawn from here. This is the resultant. That's the resultant. Okay? So, resultant in this case, when the angle is 60, meaning the angle is no longer 180, the angle is not 0, the angle is now 60. This is what you must draw. You don't even need drawing. So r squared equals 6 squared plus 8 squared plus 2 times 6 times 8 cos angle between them. That's cos 60. That's cos 60. You just pick the forces and cos 60. So r squared is now 36 plus 64 plus 96. Please, what's cos 60?
0.5.
God bless you. Thank you very much. Thank you. So r squared is now 100. You must multiply this by this before you add this to it. Don't say 36 plus 64 plus 96. That's wrong. This times this is 48. So r squared is now 148. What's now r? Square root of 148. 12.17 newtons. That is the resultant. Now, the direction of the resultant, every force, every vector must have magnitude and direction. It's not optional. Every vector must have magnitude and direction. That is not optional. Okay? So what is the direction of this resultant? Now, listen to me very well. Direction of resultant here means the angle which the resultant makes with the 8 Newton force, or the angle it makes with the 6 Newton force. There are 2 angles the resultant has made. The resultant has made how many angles, class? 2 angles. The resultant makes angle with 8 Newtons. Don't ever say to the horizontal, no, except the diagram is drawn for you. Except the draw diagram for you. The resultant makes 2 angles. It makes angle with 8 Newtons. It makes angle with 6 Newtons. Let me find the angle it makes with 8 Newton force. Who can tell me? What's the value of this case? What's the value of it? 6 Newtons. God bless you. What's the value of this case? Anybody? 8 Newtons. Because if there is 6, there will be 6. If there is 8, there will be 8. Okay? So, what do we have now? We have sine alpha, that's sine of this angle, over the side that faces it. I'm applying sine over here. I'm applying sine on it. Sine alpha over the angle, the side that faces equals, please, who can tell me what is the value of this angle here? Check where. What's the value of this angle, class? 60. God bless you. How do we know? Yeah, see how to know. Look at how to know. See how to know. This line is the same as this line. Am I correct?
Yes, sir.
This line is the same as this line. Am I correct? Angle this line and this line make with each other is 60. Therefore, angle this line and this one make must be 60 also. Confirm is correct for me. God bless you. So if here is 60, what will here be now, class? 120 degrees. That's 120 degrees. If here is 60, here is 120. So I will say what? Equals sine 120 all over R. God bless you. So sine alpha over 6. See what I have done. Look at it. So it doesn't look too clumsy for me. I've completed the parallelogram. This is the resultant. Here I was looking at 60 before. This is the alpha I'm looking for. And I said, if here is 60, here too must be 60. For this line, now this line. This line is this line. Is that okay? So, and I said what? If here is 60, here will be what? 120. Because it's angle is straight to what? Angle is straight line. So, and I'm going for what? Sine of this over the side that faces it equals sine of this over the side that faces it. That was what I did on the board here. Is that okay, class? Alright, good. So let's get that alpha. Let's get alpha. So sine alpha equals 6 sine 120 all over 12.17. Who knows what I did? I've made sine alpha the subject of formula. I took 6 to that side. I replaced R with 12.17 equals sine alpha. What's that sine alpha? What's sine 120?
0.5. Everything 0.427.
0.427.
Everything.
8660. Thank you. Over 12.17. So sine alpha equals here. This times this over this. What's the answer?
0.427.
0.427. 7. Yeah. So alpha is now what? Outside of 0.4270. Answer 25.3 degrees. Now, who can tell me what does this alpha stand for? God bless you. Perfect. That this angle means the direction, the angle, the resultant makes with the 8 Newton form. You now say, therefore, R equals 12.17 Newton at 25.3 degrees to the 8 Newton force. This is how the report answer. That's how the report was answer. Who can tell me what angle did R make with 6 Newton force? Who can tell me? What angle?
12.17 Newton at 34.7.
34.7 degrees. God bless you. The angle, watch you. Angle are made with what? with 6 Newton force, is simply 60 minus 25.3. What do you call that? 30 what?
34.7.
34.7 degrees. How do you know that? Look at the board. Look at the board. Class, look at it. What's the whole of this angle? What's everything here?
60 degrees.
60 degrees. That means if here is 25.3, what will here now be? That is 60 minus this. Is that clear, class?
Yes, sir.
Good. We have report your R again. Your R is also 12.17 newtons at 34.7 degrees to the 6 Newton force. Please, this how to present answer is one of these that will be the options. It's one of these that will be the options, not both of them, because both are correct. But don't forget, you must find both angles. Your R made angle with 8 newtons. Your R made angle with 6 newtons. We have gotten this angle as 25. How do we get this angle here? Total of this angle is 60. That means just remove alpha from 60. Yeah, you will not get what? The angle left here. There are 2 angles the resultant has made. Let's go to the next thing there. What's the next question? Good. When the forces are perpendicular to each other. When the forces are perpendicular to each other. This is one force. This is another force. This 8 newtons. This 6 newtons. These 6 newtons. The forces now act perpendicularly to each other. Is another way of saying that what? Is another way of saying the forces are at angle 90 degrees to each other. Good. You should just put 90 degrees in that formula. Just put 90 degrees in that formula. You'll get answer. Good. This is the resultant. Watch. The resultant is always the point of intersection of the 2 forces. The point of intersection of the line of action of the 2 forces. This line of action and this line of action intersect here. That is the point you will draw your resultant from. The point you will draw your resultant from 8 to what? To 6. This is the point where they meet. Your resultant is just R squared equals 8 squared plus 6 squared. So R squared is 64 plus 36. And that's what? 100. What's that R? Square root of 100. That's 10 newtons. Thank you very much. What is the direction of your resultant? Angle the resultant makes with the 6 newtons. Call it alpha. And also angle the resultant makes with the what? 8 newtons. There are 2 angles. Angles made with 6, angle made with what? 8. Okay? So, your direction is simply what? Draw this thing down like this. If you apply sine, you can do that. It's allowed. You can say sine alpha over this equals sine 90 over this. It's allowed. But take note, to find direction, you can apply tan alpha equals vertical force over horizontal force. God bless you. Tan theta is opposite over adjacent. Vertical forces over horizontal forces. Mute yourself. Mute yourself. Thank you. So, what's the vertical force? This is the vertical force. Who can tell me what's the value here in class?
8 newtons.
8 newtons. And the value here is what?
6 newtons. Newton.
6 Newton. This is now 8 over 6. So, can alpha equals, what's 8 over 6?
1.33.
1.333. Alpha is now what? Arctan of 1.3333. Answer, class.
53.12.
That's the answer. Yeah, report your result now. Your R equals 10 newtons at 53.1 degrees to the what? 6 Newton force. The 6 Newton force. Most of the students don't know how to report this. They know how to get there. They know how to get this angle. But they don't know there's another angle after this. They don't know. And they will not draw for you in exam hall. They only give you statement question. You only get statement question. They will never draw for you. So please learn that. It's very important. So, or tell me, what angle does the resultant make with the 8 Newton force? Anybody?
36.9.
It's what?
36.9 degrees.
Good. So angle R made with 8 Newton is simply 90 minus 53.1. Answer 36.9 degrees. How? These guys, 8 and 6, are perpendicular. Perpendicular means they are at angle 90 degrees to each other. The whole of this angle is 90 degrees. The whole of this angle is 90 degrees. And by virtue of that, here will be what? 90 minus alpha. Remove alpha from this whole angle 90. Remove this alpha from this whole angle 90. You will get this. This is angle. We have report your R again. Report your R again.
10 Newton.
R is 10 Newton
at 36.9 degrees.
36.9 degrees.
To the 8 Newton force.
To the what?
8 Newton force.
God bless you. God bless you. So there are two ways to report your R. In your exam, see how you test it. Option A we have 10. Option B we have 10. Option C we have 10. Option D we have 10. Because they know that every student, every Tom, Dick and Harry will get what? 10. But only those who know it will put the angle correctly. There are 4 ways they will say the question. They will say 10 Newton at 53.1 degrees to 6 Newtons. They will say 10 Newton at 53.1 degree to 8 Newtons. They will say 10 Newtons at at 90 degrees to 8 Newtons. 10 Newton at 90 degrees to 6 Newtons. We know that there's only one answer that will be correct. But announcement, these two are correct. And both cannot be option. Both can be in the word options. Except you have option E. They now say A and B. For they will say what? I. Give me statement. I. A statement. I. A statement. Statement like what? Like this. And plus the extra one I just formed. Only one answer is correct. But there will be 2. 1, 2. If you don't know how to place the angle with the force, you don't understand the topic. Good. Alright. Let's go on. The next one is at what? What's the class number 5?
When forces are at 120 degrees to each other.
When the forces now are at 120 degrees to each other. Good. How do you draw? Anyway, draw the 2 forces and put them at angle 120. Let me see what you draw. So, if you have drawn it, do you draw 120 like this?
No.
draw 120, you must show this. This is, let's say 8 as you like. Put here as 6 as you like, it's your choice. You can put 6 here, 8 here. You can put 6 here, 8 here, it's your choice. At angle 120 degrees. You draw everything like this. Complete your parallelogram. Complete your parallelogram. Yeah. So, these 6 newtons and these 8 what? Newtons. Okay? The resultant will be drawn from here. Note, don't forget that. Where the resultants are drawn from, they are always drawn from the point of intersection of the two forces. From the point of intersection of the two forces. So, this is your 120 degrees. Okay? Now, this is your resultant. You see the same formula. R squared equals P squared plus Q squared plus 2PQ cos theta. Okay? So your P is what? What's your P? Anyone? 6. Q is anyone like, yes, you are correct. 8, 6, you are correct. You are very correct. Anyone can come first. Cos what? 120 degrees. So punch this. 36 plus 64 plus 2 times this 96. But cos 120 is minus 0. That is minus 0.5. Minus 0.5. This is now 100 minus 48. So R squared is now, what's that? 52. So R is now what? Square root of 52. Answer
7.21.
7.21 newtons. Direction of the resultant is the angle which this resultant makes with the force. Let's call here alpha. Now, direction of resultant is the angle the resultant makes with what? Your 8 newtons. With your 8 newtons. Is that okay now? Yes, so what do you do here? You do what? You say what? This, what? Let's not forget. This line is the same as this. This line is the same as this. So if you make angle 120, here too we make angle 120. Am I correct, class? And this angle 60. This angle 60. Okay? So what do you have there now? We now have what? Sine alpha over, please, what's facing this place? What's there?
6 newtons.
6 newtons. It's 6. It's 6. It's 6, yeah. Your own can be 8. It depends on how you draw it. Equals sine 60, that's 1 here, that face up. Sine 60 over what? Over R. So our sine alpha is now 6 sine 60 all over, what's R? Our R is 7.21. So sine alpha is now 6 times, what's sine 60? Over 7.21. What's that alpha? Outside of punch this over this. Punch out. 0.72. So what's that alpha? 36.86 degrees. That's 0.1.
0.1, yes.
0.1. Yeah, I'm going to check your own. Check your own.
6.1.
Thank you. Yeah, report your resultant. Report your R for me. R equals
7.21 newton and 46.1 degrees to the 8 newton force.
To the what?
8 newton force.
To the 8 newton force. So what angle is your R making with the 6 newtons? What angle is your arm making with 6 Newton?
73.9.
That's what? 120 minus what? Minus 46.1. Answer.
73.9 degrees.
Good. That's the angle he's making with what? With 6 Newtons. How do you get that? The whole of this is 120. The whole of this is 120. Here is 46.1. The remaining will be what? 120 minus 46.1. Give me the final answer. R equals what?
7.21 Newton at 73.9
So,
to the 6 Newton force.
Yes, you're correct. Thank you. That's how to do all this. So, I'll get you some questions that you will do all later on this aspect. Let's go to the next one. Okay, let's write. Resolution of forces. Resolution of forces. Resolution of forces. Resolution of forces. Resolution of what class?
Forces.
Forces. Thank you. Good. Thank you. Right. This involves breaking a force. It involves breaking a force or several forces. It involves, mute yourself. It involves, thank you. Mute yourself. It involves breaking a force or several forces into two perpendicular axes or components called horizontal component and vertical component. This involves breaking a force or several forces into two perpendicular axes or components called horizontal and vertical components. See the board. I want to break many forces. This is the vertical component. This is vertical. We call it summation what? Fy. This is horizontal. We call it summation what? Fs. Summation Fy means you have added together all the horizontal, all the vertical components. When you add all vertical components together, we get summation Fy. When you add all horizontal components together, we get what? Summation what? Fx. The resultant of all of them, the resultant force R will be obtained from R squared equals summation Fs squared plus summation Fy squared. Just what we did when two forces are at 90 degrees to each other. The same thing that we did. It's the same as when two forces are perpendicular to each other. The direction of your R, let's call it alpha. Alpha is always arctan of summation Fy over summation what? Fs. Vertical value over horizontal value. This is how to get your, what's it called? Your angle direction. Don't forget, there are two angles. The resultant. This is the direction of resultant. This is the direction of resultant. This is the direction of resultant. Okay? This is the direction of resultant. So alpha, your arm can make two angles. We have been saying that. You can make angle with Fs or make angle with F1. But if you know one, you know both. Am I correct?
Yes, sir.
Thank you. Thank you. Let's take this one down. Example 1. And question 1. Determine the vertical. Determine the vertical and horizontal components of a 6 Newton force acting at angle 60 degrees to the horizontal. Determine what? Vertical and horizontal components of a 6 Newton force acting at angle 60 degrees to the horizontal. Yeah, fast. I'm waiting. You have to find. Look at it. There are 2 things you watch out here. Watch out for here. Angle 60 to the horizontal. So let's see. Look at the board. Look at the board. Here is the force here. The force is what? 6 Newtons. And it's making angle what? It's making angle 60 to the x-axis, to the horizontal. The place where the angle is positioned is very important. How do you find your Fs? Your Fs is always that force cos of the angle. Your Fy is always that force sine of the angle. But make sure, class, hear me, make sure the angle is made with the horizontal. To insist that Fs is a force cos the angle, Fy is a force sine the angle. Make sure the angle is to the horizontal. Very, very important. Extremely important. Take note of that. Yeah, please punch this for me, class. 3 Newtons. Punch this for me. 6 sine this, 4 point what? And break it down.
5.2.
5.19 is okay. Good. These are the horizontal and vertical forces. Question 2, right? Question 2. This question 1. This question 1. This question 1. Are you with me, class?
Yes, sir.
Determine the vertical. You're writing. Determine, question 2. Determine the vertical and horizontal component of a 10 Newton force acting at, yes, determine the vertical and horizontal component. You can't hear me. Nobody can hear me. You can't hear me. You can't hear me. Can you check? Can you hear me now? Can anybody? We are fixing nobody. Once you can hear me, just tell me. Can anybody hear me?
Talking.
Can you hear me now?
Yes. No. Yes, I am.
It's the headphone.
Yes. Yes, sir.
Okay. Just hold on. Let me connect the headphone. Or is it off?
No, it's not off. Okay.
Camera sister. Camera sister. Can you hear me now? Yes. Okay, yeah, let's get fast. Alright, thank you. Right. Determine the vertical and horizontal component of a 10 Newton force acting at an angle 60 degrees to the vertical. To the vertical. Keyword vertical. Your angle is now to the vertical. It's no longer to the horizontal. Who is done with that? Good. Who is done with that? You have to get calculator. Good, thank you. In this case, the force makes angle 60 degrees with the vertical. Yeah, look up, please. Look up, class. Look up. The force makes angle 60 with the what? Vertical. Now, my S component is that force cos. My Y component is that force sine, but I will not use angle to vertical. I will go and use angle to the horizontal. So I will say what? Cos 30, sine 30. So when we say that our air, they can be sine 60 now, they can be cos 60 here. You are correct. You are correct. I want to use throughout angle to the what? Horizontal. So that I can maintain S is cos, Y is sine. But if you are good, you know what you are doing already. If it's angle to vertical, S is now sine, Y is now cos. But please, don't get yourself confused. Don't get yourself confused. Always use cos for S, sine for Y. What's the answer, class? What's cos 30? That's 8.66 newtons. What's this one? 5 newtons. Good. Last question for today. Can you hear me? Yeah. So, last question for today. So let's see it. Determine the resultant force. Determine the resultant of the following forces. Determine the resultant of the following forces. Determine the resultant of the following forces. My body is, I'm so wet because of just my exercise. So my clothes is wet. Just came from feed to the class. So let's go. You have to find the resultant of the following forces. This is 6 newtons. This is 4 newtons. This is 6 newtons. This is 2 newtons. This is, just watch, this is 10 newtons at angle 60 degrees. You have been asked to find the resultant of these forces. You have been asked to find the resultant of these forces. You have been asked to find the resultant of these forces. Please mute yourself so I can explain this for the last time today. Mute yourself, thank you. Mute yourself. Somebody's still on. Somebody's still on. They are still in the class. Anytime you see a force like this, you must resort to S and Y. If you see a force like this, resort to S and Y. If you see a force like this, result to X and Y. If you see a force like this, result to X and Y. If you see a force like this, result to X and Y. It's a must. It's not optional. If you see a force here, it's purely X already. This is X value. If you see a force here, this is pure Y value. If you see a force here, Y value. If you see a force here, X value. And take note of the sign. Take note of the sign. In your graph, positive Y axis. This is positive Y axis. This is positive X axis. This is negative X axis. This is negative Y axis. Therefore, watch. If you see a force on the X axis like this, you give it plus. If you see a force on the Y like this, you give it plus. If you see a force on the Y like this, you give it minus. If you see a force like this, you give it minus. If you see a force that acts like this, what do you give its X value? Plus. What do you give the Y value? Plus. Because it's in a place where both X and Y are plus. If you see a force here like this, what do you give its X value? Plus. You give its Y is what? Negative. Good. If you see a force here like this, you know, every force like this has X and Y. We have done that. I mean, every force like this must have X and Y. Every force like this must have S and Y. Every force must have S and Y. So you see a force here like this. It has S value, it has Y value. But its S value now plus, its Y value now minus. Because it falls in a place where X is plus, Y is minus. Let's do this thing now. We want to do watch class. Which force, look up, which force, look up, which force do I need to resolve here? Do I need to resolve 6? Yes. Is already Y. Do I need to resolve this one, this 6? Is pure X. Do I need to resolve this 2? Is pure Y. Do I need to resolve this 4? Is pure X. I mean, do I need to resolve this 10? Yes. So let me go and resolve this 10 new things. Let's resolve it. What's the fx of this 10? 10 cos 60. Abi? Yes, sir. What's the answer? 5 Newton. Is it plus or minus? Plus. Is it plus or minus? Plus. Why is it plus? Why is it plus? Because it's in the positive side. It's in a place where X is plus. This plus X axis, plus Y axis, negative Y axis, negative X axis. So this, what's the Fy? What's the Fy? 10 sine 60. 60, Abi. What's the answer? 8.66 Newtons. Is it plus I will give it or minus? Plus. Plus or minus? Plus. Why is it plus? It's in a place. Y is positive. Y is plus in this place. We are class. Let's listen. What is the summation of all the S forces? How many forces are S on the board? How many forces? 3 forces. 6, 4, and 5. Where the 4 here, is it plus or minus? Plus. The 6 here, is it plus or minus? Minus. The S I got here, is it plus or minus? Plus. What's the final answer? What's the final answer? 3 Newtons. And it's plus. I mean, what's summation of all the Y axis? All the Y forces? Where is Y first? How many Y are on the board?
3.
1, 2, and this. Abina?
Yes, sir.
Don't forget I resolved this 10 into this. Let's go. Let's go. Plus 6. That's this. Plus 6. Abina?
Minus 2.
Yeah, but this one go
Minus 2.
minus 2. Abina? Then this 10. What is Y? What is Y?
Plus 8.66.
What's the final answer?
1.6.
Newton. God bless you. Oh yeah, let's now draw it. Go draw it. Let's draw it. Oh yeah, where do I put my 3? Is it right or left? Right or left? Why is it right? Why is it right?
Because it's positive.
Positive. Where do I put my 12.66? Up or down?
Up.
Why is it up?
Because it's positive.
Good. Where will I put my resultant?
So you mean the name of yeah.
This is my resultant. I mean,
Yeah.
so you can see what? We have turned all these forces. We have turned all these forces into what? Into just 2. 1, 2. Am I correct?
Yes, sir.
What is now the resultant? Resultant R squared is summation of all the x squared plus summation of all the y squared. So R squared is now, what is it? 3 squared plus what? 12.66 squared. So R squared equals, what's this plus this? Give me the whole answer. 169.27. Final answer. Punch it. No. 13 point. Good. What direction? Class. Direction. Alpha is half tan. Half tan of what over what? Vertical over horizontal. Have you heard? What's like the alpha? .7 degrees. Which the angle R makes with what? Angle horizontal makes with what? With 3 newtons. What angle will it make with 12.66? Here is 76.7. Here is 13.3 degrees. So R is now what? 13.01 newton at 76.7 newtons to the x-axis. Or R is 13.01 newtons at 13.3 degrees. Yes, degrees to the y-axis. In this case, you are free to use x and what? Y. You are free to use x and y now, because we actually result to x and y. That's the end of today's class. That's the end of today's class. Is that okay now? So, take this assignment, right? Take this assignment. Are you following me? Yeah, take this assignment. A dispatch rider. Right, writing. A dispatch rider. A dispatch rider. How do you spell dispatch? D-I-M. A dispatch rider follows the following routes. Follows the following what? Routes. To deliver a package. To deliver a package. To deliver a package. Right. 12 kilometers eastward. 12 kilometers eastward, comma. Then 7 kilometers northward, and finally, 2 kilometers in the direction 30 degrees north of east. North of east. How do you see northeast? Northwest. Yeah. A dispatch rider follows the following route. A dispatch rider follows the following route to deliver a package. Are you there? 12 kilometers eastward, then 7 kilometers northward, and finally 2 kilometers in the direction 30 degrees north of east. Full stop. Determine the displacement. Determine the displacement of the rider. Determine the displacement of the rider. Determine the displacement of the what? The rider. What is the rider's displacement? First to submit, you will get 2 notebooks. First to submit, but you will be correct. Submit and correct answer. It's a cheap question. Once you are done with it, snap and send to me. You have my WhatsApp number already. Snap and send to me. First to submit, you get 2 notebooks. Yes, I hope this guy is around. They always ask for notebook. I hope you are around. Good. I hope you are around. So do it and